Hello dear student, once again welcome to my channel Maths in Minutes with Priya. Today we are going to deal with fractions, decimals and their convergence, that is fraction to decimal and decimal to fraction. But before moving to this convergence, I want to clear some basic concepts. Now these concepts you have learned maybe in primary or maybe 5th or 6th standard, but still I want to clear these fundamentals because in my so many years of experience I have observed that many students, they do not know actual meaning of fraction and why they need to convert. They do not know it, and that's why I'm going to cover first basic concepts. Some of you may find it very primary, but still watch it till end because we are going to cover convergence also. Suppose there is a birthday party at your house and you bought a 3 kg cake of Monginis. You are expecting say some 25 guests. So what you do? You cut that cake in 25 pieces so that you can distribute it evenly. Am I right? And then you keep those pieces ready in a plate, say. So everybody comes and takes a piece. So from 25 pieces, they take one. So that whole cake was cut into 25 pieces and everybody takes one piece. That means they take fraction of cake. So fraction means a part of a number. So here we are talking about cake. So that whole cake, people are only taking one part. That means they are taking 1/25 of the cake. Since I have cut cake in 25 parts, now my denominator becomes 25, and when everyone takes one part, so they are taking 1/25 of the cake. But what happens? A child says, I want one more. So what he does, he takes another piece. That means now out of 25 he is taking 2 pieces. That means he is eating 2/25 of the cake. Another child comes. He says, I want one more piece for my friend and 2 more for my sister and 1 for me. So what he is doing? Total he is taking 4 pieces out of those 25. That means he is taking 4/25. That fraction of cake he is taking with him. That is the meaning of fraction. So when we say 3/5, it actually means cut the given thing in 5 equal parts. These are 5 equal parts and you take 1, 2 and 3. These 3 out of it. This is 3/5 and this is 2/5, which is still left. So if this is a number, out of it you are taking 3/5 and 2/5 is left in that number. If this is a biscuit, you are eating 3/5 and then 2/5 is still left in that biscuit which someone else can eat. Same thing, 7/8. What does this mean? You make 8 equal parts. These are 8 equal parts, out of which you are going to take 7. So these 7 I am taking. And this one will be left. So 1/8 is left here and 7/8 is gone. 7/8. So if this is a biscuit, I am eating 7/8 and 1/8 I am again keeping back in the container. Now 3/5 you understood. But what is 5/3 then? This is 3/5. But what is 5/3? When I say 3/5, I say that out of 5 I am taking 3. But when I say 5 upon 3, does it mean out of 3 I am taking 5? It is not possible. You cannot take 5 out of 3 because 3 is smaller. So now let's understand meaning of this type of fractions. They are known as improper fractions. This is proper fraction. This is improper fraction. In proper fraction, numerator is less than denominator. Numerator is less than denominator. And here you see 5 is more than 3. So numerator is more than denominator. This is proper fraction. Proper. This is proper fraction and this is known as improper fraction. Then what is the meaning of improper fraction? Why do we need it? Now let's understand that. One thing you must remember, value of improper fraction is always more than 1. This is more than 1. Now how to find? 5 upon 3 means 5 divided by 3. When I divide 5 by 3, what do I get? Quotient will be 1. 3 ones are 3. Remainder will be 2. And then copy this as it is. 1 integer 2 upon 3. Value of 5 upon 3 is 1 integer 2 upon 3. Some also call it 1 2 by 3. That is same as 1 integer 2 by 3. Meaning of this is 1 plus 2 by 3. That is the meaning. That means I am eating one biscuit full and from second biscuit I am eating 2 by 3. That is I am eating one biscuit full and from second biscuit I am so hungry that from second biscuit also I am eating 2 parts. So this is left. 2/3 I am eating, 1/3 I will keep back in the container. So I am eating 1 plus 2 upon 3 of second biscuit. That is the meaning of improper fraction. This is also known as mixed number because this is whole number and this is fraction. They are mixed together, hence they are also called as mixed numbers. So improper fraction. So you see here, this is more than 1. 1 plus some part of second biscuit also. 1 biscuit plus some part of second biscuit. So it is always more than 1. When numerator is more than denominator, value is always more than 1 and this is the way you convert it. So 1 2 by 3 is same as 1 plus 2 upon 3. Let us convert this. Here we understood 7 by 8. But what is 8 by 7? So again 8, it's like this. 8 divided by 7. So what do we do? 7 ones are 7. That's how we do. So what is the quotient? Write quotient here. 1. What is the remainder? 1. And this is copied as it is. So this is 1 plus 1 by 7. That means I am eating one biscuit full and from second biscuit I am going to divide second biscuit in 7 equal parts. And from this I am going to eat only one part. I ate one biscuit and from second biscuit I ate 1 by 7 and this 6 by 7 again I kept in the container. So 8 by 7 means 1 by 7, that is same as 1 plus 1 by 7. Is the meaning of mixed number very clear? Improper fraction converted into mixed number. This is mixed number. Now let us convert some more. This is very important. You need to be very fast because in many examples that we are going to solve for simplification or for many other chapters, improper fractions keep on appearing and mixed numbers also keep on appearing. Sometimes we need conversion from here to here, sometimes from here to here. So let us practice 5 or 6 so that we can move ahead to decimals. Improper fraction 15 upon 4. How do we convert? Divide 15 by 4. So 4 3s are 12. Remainder will be 3, so it goes in numerator, and copy this as it is. So it is what? 3 plus 3 by 4. So I am eating 3 biscuits, and from 4th biscuit I am also eating 3 by 4th, and 1 by 4th I will keep in container. This is 3 plus 3 by 4. 43 by 7. 7 6 is 42. Divide 43 by 7. 7 6 is 42. 1 is the remainder. Copy 7 as it is. So it is 6 plus 1 by 7. 6 full plus from 7th number or 7th biscuit I am taking 1 by 7. 57 divided by 11. 11 5s are 55. 2 will be remainder. Copy 11 as it is. So this is 5 plus 2 upon 11. These all are improper fractions and their value is always more than 1. It can be anything, but definitely more than 1. Value of improper fraction. Now let us do it reverse way. Mixed numbers are given to you and you now need to convert them to improper fraction. So what you will do? Do this multiplication. Take their product. 8 5s are 40. Add 3 to it. It becomes 43. Copy this as it is. 25 is 100. 100 plus 3 is 103. Copy this as it is. 10 multiplied by 11 is 110 plus 7. 117. Copy 10 as it is. So here we converted mixed number into improper fraction. We needed to multiply and then add. And here it was improper to mix. So here we divided. Are you getting the difference? Take any number and keep practicing and you should be very fast in this. Fractions can also be written in decimal form. Just now we saw numerator upon denominator type of form. Now let us see decimal form. Now I have written here 0.7. What does this mean? I am going to now convert it into fraction. That is numerator upon denominator. That type of form I am going to convert it. Number is 0.7. I want numerator upon denominator. Basically, if I try to write it in the form of n upon d, this is what? 0.7 upon 1. Right? Any number I can write as that number upon 1, meaning remains same. So now how to convert it? Remove this decimal. How many places you are removing it? You removed it one place. So give here 1 0. So 0.7 becomes 7 upon 10. 0.7 becomes 7 upon 10. You removed one place. You moved this decimal one place and you give 1 0 here and it becomes 7 upon 10. Let's see few more examples. This is same as 0.29 upon 1. Now I am moving this decimal point two places, 1 and 2. Two places I am removing it. So now I have to give here 2 zeros. So this becomes 29 upon 100. Just move. Here there are how many places after decimal? There are 3. So what I need to do? I am moving the decimal 3 places. So I will give here 3 zeros. So this is 568 upon 1000. So look here what we did. Just count the number of places after the decimal point, number of digits after the decimal point. After decimal point, there is only one digit. So copy this 7 as it is, and since there was only one digit, give 1 0. Here there are two digits, so give 2 zeros. Here there were 3 digits, so give 3 zeros. It is as simple as that. So decimal form can be very easily converted to fraction form. Just move that decimal point and add that many zeros in the denominator. See here now. So what I have to do? Copy numerator as it is. 08 means 8 only. And denominator, how many places after decimal point? 2 places. So give 2 zeros. This is 8 upon 100. This will be what? This is 9. And how many places after decimal? 1, 2, 3. So this will be 1, 2, 3. 1, 2, 3, 4 places. So this is 72. In the denominator it will be 1, 2, 3, 4 zeros. Just count number of places or number of digits after decimal point and add that many zeros to 1 in the denominator. Now these all were 0 point something. Now let us take something greater. Now this is 3.4. 3.4. So what I will do? Just copy this number in the numerator. Same way here also we just copied this number in the numerator. Same way here also we are just going to copy this number in the numerator, and denominator what we will do? How many places after decimal point? Only one place. So add this 1 0. Only add 1 0 to this 1. Copy this number as it is. 5.08. So write 508. And then in the denominator add 2 zeros, that is 100. Copy this number. This is 9639. Copy it as it is and then add 2 zeros. Very easy. Now let's do it in opposite direction. Here what we did? Decimal form was given to us and we converted into fraction. Now suppose this is given to us and now we need to convert it into fraction form, that is numerator upon denominator form. Then how to convert it? This is 7 upon 10. So copy this as it is again. Copy this as it is and then count the number of zeros in the denominator. How many zeros are there? Only one. So here give a decimal point. From right hand side to the decimal, count the number of digits. Here only 1 0, so I need only one digit here and that is 7. So this is 0.7. Let's understand it with few more examples. Copy this number as it is, 29 as it is. How many zeros? 2 zeros, so I need 2 decimal places after decimal point. This is 1 and 2, so give a decimal here. That's all. It becomes 0.29 or 0.29. You can call it anything. 0.29 is same as 0.29. Here. Copy this number as it is. 5, 6, 8. How many zeros? 1, 2, 3. 1, 2, 3. So give a decimal point here. We need 3 decimal places since there are 3 zeros. Copy this as it is. 8. How many zeros? 2 zeros. Now remember we are going to count digits from right to left. So there are 2 zeros. So this is 1. And we need, how many places we need after decimal point? There are 2 zeros. That means we need 2 places after decimal point and we are going to count it from right to left. So this is 1. Then give a 0, 2. Now there are 2 places. Now give a decimal point. So see, now there are 2 places after decimal point. So this is 0.08 or 0.08, one and the same. 9. So copy 9 as it is. How many zeros? 1, 2, 3. So start counting. This is 1, this is 2, this is 3, and now give a decimal point. 72 copy as it is. 1, 2, 3, 4. 1, 2, 3, 4. Then give a decimal point. 0.0072. It's same as 0.0072. No difference. 34 upon 10. Copy this as it is. 34. How many zeros? Only one zero. So we need one place after decimal. So put a 0 here. This is 3.4. 1 0. So one place after decimal from right to left. 508. Copy this. How many zeros? 1, 2. So count from right to left. 1, 2. Give a point here. 5.08. 9639. How many zeros? 1 and 2. Copy from right to left. 1, 2. Give a decimal point here. Is this very clear? See, these conversions are very important. As I said, every now and then in each and every chapter that we are going to do for this complete quant section or secondary school maths, you must be very fluent in this conversions. They are very, very important. Now in this conversions, it was very easy because denominator was 10, 100, 1000, 10,000, anything. So 1 followed by few zeros, so you easily added a decimal point. It was very easy because of this denominators. But is it possible that every time only this type of denominators will be there? Denominators can be there of any type, and whatever number we get in fraction form, we must be able to convert it into decimal form, right? So now let us see those examples where denominator is not 10, 100 or 1000, it is something different. Now we are converting fraction to decimal where denominator not in the form of 10, 100 or 1000. See here, now fraction is 39 upon 4. How do we carry this division? Now this is basically 39 divided by 4 only. This division you have learned maybe in first or second standard, I don't know, I don't remember actually. When I divide 39 by 4, how do I divide? 4 9s are 36 and then the remainder is 3. Up till this point, you know, you have already learnt it. But now how to give a decimal point? Now this is 3 which is less than 4. So it cannot be divided further. So what do? We give a 0 here and then we give a decimal point here. At the same point, when we give 0, when we add 0, at that point only we need to put a decimal point. Now 4 and 30. So carry out normal division again. 4 7s are 28. This is 2. Again give a 0. Now 4 5s are 20. So keep doing it till you get zeros. 0. So now it is complete. 39 upon 4 is 9.75. I have now converted it to 9.75. 39 upon 4 is same as 9.75. Another example. 594 upon 8. I need to convert it to decimal. So how to convert it? Again carry out your normal division. 594 upon 8, carry out your normal division. 8 7s are 56. 4 here. 8 4s are 32. Up to this point, everybody knows how to do the division, very easy. Now 2 is less than 8, cannot be divided further. So give a 0 here and at the same time add a decimal point here. Now 8 and 20, 8 2s are 16. 4. Keep doing it till you get 0. Now add 0, 8 5s are 40. Now the remainder is 0, so our division is over. 594 upon 8 we have converted to 74.25. Are you getting it? Now if we look at these two fractions, they were improper fraction, that is numerator was more than denominator. So it reflects in our conversion also. This is 9.75. This is more than 1. Improper fraction is always more than 1. So see here it is 9.75. It is 74.25. These were improper fraction. But how to convert when they are proper fraction, that is numerator less than denominator? Now let's see that. The next number is 3 upon 4. Numerator less than denominator. So this is a proper fraction. And how to convert it? 3 goes here, 4 here. Here when we did it, this was more than this. So first part we got easily and later we added a decimal point. But here at the starting only this is less than this. So what we need? We need a 0 because 3 cannot be divided by 4. So I am going to give a 0. And what is the instruction? When you add a 0 at the same point you give a decimal point here at the same time. When you add 0, straight away give a decimal point. Now this is 4 7s are 28. And now we have to keep on doing it till we get 0 remainder. This is 2 and this is 4. Add a 0. 4 5s are 20. So our division is complete. 3 upon 4 is 0.75, or we can also write it as 0.75. Very clear? Let's see one more example. 3 upon 16, that's my next fraction. Now I'm going to convert it to decimal. 3 goes here, 16 here. 3 is less than 16, cannot be divided further. So 0 here and a decimal point here. 16 ones are 16. This is 14, which is less than 16, so 0. 16 8s are 128. See, you should be very good in tables so that you are fast in the calculations. Again a 0. 16 7s are 112. Again a 0. 16 5s are 80. And now the remainder is 0. So I have converted it into 0.1875 and my conversion is complete. Did you get it? So here we tried 2 proper fractions and 2 improper fractions. You have to keep on doing it. Take any fraction and try to convert it. As much as practice you do, as much as tables you by heart, that much you will gain in your speed. Speed is very important along with accuracy. So please keep on practicing. Next video will be sort of continuation of this only, in which we are going to learn recurring decimals and conversion of recurring decimals to fractions and fractions to recurring decimal. If you haven't yet subscribed to my channel Maths in Minutes with Priya, please do so. I'm waiting for your likes, comments and suggestions. So let us meet in the new video. Till then, keep by hearting table, stay happy, stay blessed. Bye for today.